Thank you, Steve. So of course, at Navis, we have decades of experience with automation, starting with terminals like ECT and Euromax in Rotterdam and HHLA CTA in Hamburg. And these were, of course, really the first terminals to dive into equipment automation. A wave of semi and fully automated terminals followed around the world. Most of these terminals were greenfield builds, and now we are seeing as many greenfield automation as brownfield automation projects. And with brownfield automation, you have the additional challenge of keeping your terminal operational at your required service levels while you deploy automation. And for over 20 years, Navis has used artificial intelligence in our solutions for solving complex problems, especially the various non-deterministic polynomial acceptance or NP-hard problems found in container terminals. With modules like AutoStow, Prime Route, ASC scheduling, and RTG optimization, which all use AI to solve problems which can take hours, days, or even longer to solve manually. As terminals pursue equipment automation, often decision automation modules are needed to reduce tedious tasks, or even tasks which are impossible for a human to perform well quickly. As processes and decisions are automated, variability is reduced between shifts and staff levels of experience. We build automation on top of optimization to help terminals get the most out of their assets and support their future growth plans. They are able to reduce change management costs as they add automation to the operation because their staff is already using automated planning and decision-making tools and organized to support an automation rollout. And as terminals standardize their processes, they can more easily automate these processes, further reducing variability. And this is an area where we often see terminals struggle. Should I choose a technology and adjust my processes to it? Or do I choose a technology that matches my existing processes? And often, a commonly made assumption is to do the latter. Look at existing process and automate this. And this can apply both for formal processes that are written down, as well as informal processes that are part of the way your terminal works. The risk we often see is that these processes are based on your current system, which relies on humans who can think, see around them, and reason with other humans. Machines can't do this. And even when terminals have a lot of automated and documented workflows, often not everything is standardized, and there's still a great variability between shifts and planning for upcoming vessels, trains, or the execution of work. The result is a lot of time and effort spent documenting known processes and finding out about informal processes, those that live in the minds of your dispatchers, planners, and drivers. And this approach, while initially logical and natural, can be time-consuming and skips over the fact that many of these processes have been created over years with their main purpose to generate a certain outcome, an outcome that an automated system or machine might be able to achieve in a quicker, unconventional, or unexpected way. So moving to automation is not so much a shift in moving from man to roboticized equipment, but a shift in mindset. It's a different way of achieving the same goals by looking at your current way of working, both formal and informal, and finding where human decisions are made, and most importantly, where you want human decisions to be made in the future. And when the sophistication and automation are added to the operation, terminals generate more data, which they can further use to optimize and fine-tune the operations. And so terminals need to adopt a continuous improvement mindset. Your staff has an inherent set of skills that automation won't immediately be able to replace. Because automation gives you the option to liberate your staff from redundant or repetitive tasks, gives you the option to remove the variability from your operation and create consistent output. And that means it's not so much reviewing and automating your existing processes or changing them for automation, but rather reviewing your processes and identifying how your staff fits into the current process and where you want them to fit in with your automation transformation. Automation will bring a new way of working for your workforce, whether they're remote or not. More data is created, more decisions are made automatically, more work is managed by less people. And it becomes about what you want your staff to see and not see, and what they should act on versus what can be automatically handled by the system. So, key part of automation is building and designing around your team's current and future skills and adjusting your internal process to allow them to become proactive exception handlers instead of reactive firefighters. It's about leveraging the creativity of people and letting machines do the routine and repetitive tasks, and making sure your processes are built and designed to support this. And this also means leveraging technology that allows you to incorporate innovation into your terminal as you grow and scale. Often, we see terminals needing to hire for new skills when confronted with this new data reality, especially data science and analytics. By relying on technology partners that focus on usability and new technologies like natural language processing, it can be easier to train and grow your staff into these new skills. And as a new generation enters the workforce, these digital tools become the standard for hiring and retaining the best talent. And analyzing this data and correlations, especially with costing data, is really important. Helps you understand when and where in your operation it makes sense to invest, such as when evaluating modernization, expansion, and automation projects. Digitalization and automation grow volumes of data, and many terminals lack the expertise to manage these growing data lakes. As terminals look to leverage the data they're producing and start to extract these from various systems, they often run into issues which can cause project delays. We've built the Navis Smart Data Platform, which allows us to not only process data faster in real time, but also enables data integration from other TOSs and different third-party applications to derive valuable correlations. And by building applications on top of this platform, our clients can subscribe to event updates and normalized forms that are designed for application consumption, saving them the hassle of building this digital infrastructure themselves. And of course, we couldn't ignore all this data being produced. As technologists and together with our customers, some of the most advanced container terminals in the world, we wanted to explore machine learning. We wanted to use this new technology to learn from data, find correlations, and predict meaningful KPIs to create future situational awareness and enabling actionable intelligence for our terminals and their customers. Actionable intelligence means having the necessary information immediately available to deal with the situation at hand quickly and efficiently in a 12 to 72 hour period. So we reviewed and considered a lot of different use cases, from predicting cargo volume, mode, timing, revenue, and cost, augmenting existing decision-making, dynamically setting software parameters, and recommended actions for the control room. Together, we decided on predicting the estimated time of completion for vessels, 12 to 72 hours before the vessel arrives, as this could provide actionable intelligence for staffing and crane assignment adjustments, buying the operations team the time to make these changes. And we use the general methodology for data science. First, we collect the data. Here we use 3 years of historical data, over 700 vessel calls, and correlated different attributes to build a model. And we use test set. Model wasn't trained on this data, but rather we tested the predictions and compared these to the real values. So we built 2 models, an extreme gradient boosting model and a deep neural network or deep learning model. And we were able to see some pretty accurate predictions with these factors. And prediction outliers, we saw we could improve this accuracy by pulling in more data from the terminal, such as the operating hours for the gate. We're now integrating these predictions across our platform so that new prediction requests are done whenever changes to the plan are made in order to validate, reinforce, and increase confidence levels for planning. And as we're looking to other use cases, such as predictive equipment maintenance and reducing empty container shuffling with our terminals. And so as you think about how to prepare for automation, I want to challenge all of you to think about how to prepare for the port of the future. And we've seen these evolutions. At first, workers linking individual process steps and direct yard operations, and then the governance of those steps through a terminal operating system, with operators making decisions in the central control tower. Removing variance and adding automated decision-making further with automated equipment and workers handling exceptions. And now, with the growing number of sensors, IoT devices, and business processes being standardized and automated, there's an incredible amount of data being produced. Terminals will use this data and tools like machine learning that are made to recognize patterns, to reduce inefficiencies, and optimize the supply chain. And we've already seen this with some of our customers using their data science teams to help with forecasting volumes to better cope with the shocks of the COVID-19 pandemic. The port of the future will be data-driven, and we are helping our customers to think about their business processes today and how they will manage their operations in the future.